Home stretch, the distributed practice that'll have to do with the stoichiometry. You'll want your stoichiometry roadmap, but more specifically, the shortcuts on how to find the wants and the givens and how many givens there will be on the back side. Stoichiometry always starts the same. We need to start with the balanced equation, so that's what I'm going to attack first. Hydrogen gas can be produced, so that's a product, by reacting magnesium with hydrochloric acid. Magnesium plus hydrochloric acid. This looks like a single replacement reaction where one element is going to replace another element and kick it out. So I'm going to have magnesium chloride as a product. I have to be careful and think through. Magnesium is +2, chloride is -1, so it's going to be MgCl2. I'm going to just try to do this by examining it. If I have 2 chlorines here, I'm going to have to double that. That gives me 2 hydrogens, and now I'm all balanced. Step 1, start with the balanced equation. Step 2, how do I identify the wants and the givens? Well, this is limiting reagent maximum yield. So if I get out my test-taking tool and find the section not about percent yield, but limiting reagent maximum yield, it says the reactants will be givens and there will be 2 or more givens. In this case, simply 2. I only have 2 reactants. I need 2 givens. I have 2 numbers. I think I've got this part figured out. That's a given and that's a given. I always write the given. Well, I might as well identify the want. What do I want to know? I want it to be in terms of grams of hydrogen. So that is my want. I have 2 givens. 6.0 grams of HCl is one of the givens. 5.0 grams of Mg is the other given. What I want to know on both cases is grams of hydrogen. So, given grams of one substance, mass of given, I'm trying to get to my grams of want, mass of want. It's straight across 1, 2, 3 steps right through the heart of the problem. So here we go. The next step has to be 1 mole of given on top. But the given in this case was HCl over the molar mass of given. Chlorine is 35.5 plus 1 is 36.5 grams. Some people might think you're supposed to do 2 moles, but we save this coefficient for the heart of the problem. When we get to the heart of the problem, we'll use information from there. In fact, we're there now. We've done this step, which has to be a 1 mole of given over molar mass of given. Next is the heart of the problem. The ratio comes from the balanced equation. Moles of want over moles of given. What was my want? Hydrogen. So moles of want goes on top. Find hydrogen. It's got kind of a 1 next to it. 1 mole of H2, which is want. Moles of given, hydrochloric acid. It's got a 2 next to it. 2 moles of HCl. Now it gets me to the next step. Molar mass over 1 mole of want. So that's molar mass of want. What is my want? Hydrogen. Molar mass of want. So what does a mole of hydrogen weigh? It's H2, so it's 2 grams of H2 over 1 mole of H2. It's got to be a 1. I double check. Crosses out, grams, grams, moles, moles, and that will be in grams. Putting these numbers into my calculator. 6 times 2 because it's on top, divided by 36.5, divided by 2 because it's on the bottom, 0.16 grams, 0.16 grams of H2. What if we started with 5 grams of magnesium as our given? Once again, we're following the same steps. We're following across from here to here to here. We're just going to have a different given to start with, so a little bit of different information. 5 milligrams, the first 5 grams of magnesium. We need the 1 mole of magnesium over the molar mass of magnesium. Magnesium is 24 grams. 24 grams of magnesium. We're at the heart of the problem. We want moles of what over moles of given. What we want to know once again is moles of hydrogen. So I'll put 1 mole of hydrogen. Why 1? Because there's 1 mole of hydrogen. This given was magnesium. We go to the balanced equation, also 1 mole of magnesium times the molar mass of want over 1 mole of want. That's just like we did right here. The molar mass of want is still 2 grams of H2 over 1 mole of H2. Crosses out, crosses out, crosses out, crosses out. Yep, I think I have it set up well. 5 times 2 divided by 24. 0.42 grams of H2. So here's what this is saying. If we have 6 grams of hydrochloric acid, the absolute most hydrogen we could possibly get out of that is 0.16 grams of H2. That's the most. If we have 5 grams of magnesium, the most we can get is 0.42 grams of H2. In other words, we don't have enough to make 0.42. We only have enough to make 0.16 grams. That is our maximum theoretical yield. Now, how do I figure out the limiting reagent and the excess reagent? No numbers go on here. These are just symbols for some substance. If I take what the maximum theoretical yield and backtrack across, this given is the reagent or the substance that limited me. Therefore, the limiting reagent is HCl. Don't say 6 grams of H. The limiting reagent is called HCl, or hydrochloric acid, which means we must have had extra of magnesium. Last one is a percent yield. Percent yield is also stoichiometry, but it's going to be found on this side. And so we're going to use this information. We know that the given is a reactant and the want is a product. Okay, so let's backtrack. First, we need a balanced equation. Silicon dioxide, SiO2, they're telling me that it's dioxide, is heated with an excess of carbon. When they tell us this, when they tell us we have extra, they're not asking us any details. They're telling us we have plenty. So that isn't going to be our want or our given. Heated with carbon, it's going to make silicon carbide. Si would have a charge of +4. Carbon has a charge of -4. I'm looking here. Silicon carbide +4 or -4. That's going to be right there. As well as carbon monoxide. Do some analyzing to find out how to balance it. It looks like with 2 oxygens here and only 1 over there, I'm going to have to double my oxygens. But now I have 2 carbons plus 1 more is 3 carbons, so I'm going to have to 3. I now have a balanced equation. What is the percent yield of this reaction? Percent yields, the given is going to be a reactant. Remember, givens always have numbers. So find a number. Oh, there's 2 of them. Which one do we use? Whichever one's the reactant. This is silicon dioxide. That is my given. Well, I'm going to write given right there. It's a reactant that has a number, 50 grams, SiO2. What I want to know is going to be a product. The only product they're going to ask us about is silicon carbide. This is my want. It looks like they told us how many we have, but that's going to be how much is produced. Sometimes it'll say the word actually produced. This one doesn't, but that's what they're saying is when they did heat this, this is what was produced. So 32.2 grams of silicon carbide. This is going to be our want, grams of silicon carbide. So where are we at on the map? We were given grams of given. We're trying to get to grams of want. We simply follow 1, 2, 3 steps to get our theoretical yield. And then we'll read the directions to see what to do next. 1 mole of SiO2 is going to be 32 for oxygen plus another 28, 60 grams of SiO2. We're now at the heart of the problem. The heart of the problem is the moles of want over moles of given. That comes from the balanced reaction. What's our moles of want? Want is silicon carbide. There it is with a 1 sort of next to it. 1 mole SiC. Given was SiO2, also with a 1 next to it. 1 mole SiO2. Molar mass of want over 1 mole of want. We want to know silicon carbide over 1 mole of SiC. Have to add that up. Carbon is 12 plus silicon is 28. That's a molar mass of 40. 40 grams SiC. Put these numbers into the calculator. 50 times 40 divided by 60. 33.33 grams. 33.3 grams. That's theoretical. Theoretical grams, theoretical of silicon carbide. So how much did it actually make? Well, they say that we actually got 32.2 grams. So I need to figure out what to do next. Check the back of the Stoic roadmap. Actual divided by theoretical times 100 turns it into percent yield. The actual was 32.2 grams divided by the theoretical 33.3 times 100. 32.2 divided by 33.3, enter, times 100, 96.7% yield. That's our answer.